In the rugged heart of Western China, a vision was born to transform a mountainous landscape into the world's largest high-speed rail hub. Located in the Nan'an district, this ambitious project required conquering complex geology and uneven terrain. Before a single pillar could rise, precise measurements were needed to tame the wild topography. Late 2018 marked the beginning of the Earthworks, mobilizing a massive fleet of heavy machinery.
Millions of tons of earth had to be moved to level the ground for the massive foundation.
Day and night, the site was a hive of activity, reshaping the very geography of Chongqing.
Safety was paramount as workers navigated the steep slopes and shifting soil. The result was a leveled canvas.
To support an 8-story vertical metropolis, deep pile foundations were drilled into the bedrock.
Steel cages were lowered deep underground to reinforce the concrete piles. Thousands of cubic meters of concrete were poured to anchor the station against the region's seismic activity. Every pour was vibrated to remove air pockets, ensuring maximum structural integrity.
The foundation work alone was a monumental task, setting the stage for the structure above. Construction never stopped, operating 24 hours a day to meet the tight deadline. But the work wasn't just on the surface. Deep underground, connections for local subway lines were being prepared. The station connects seamlessly to the Chongqing subway, requiring complex tunnel engineering.
Massive tunnel boring machines carved out the paths for lines 6, 8, 24, and 27. Waterproofing was critical to protect the station's lower levels from groundwater.
The underground levels began to take shape, serving as the future transfer hub for millions. Advanced technology was introduced early, using laser-guided bulldozers for precise ground leveling.
These machines tripled efficiency, leveling the ground with millimeter accuracy. The basement floor required a continuous, massive concrete pour, lasting several days.
Teams of workers guided the flow, covering the steel skeleton in liquid stone. Instead of manual smoothing, AI-driven laser-screed robots finished the concrete floors. This robotic precision eliminated human error and ensured a perfectly flat surface. As the foundation cured, the base for the vertical city was solidified.
Heavy steel beams were introduced to support the immense weight of the train tracks above. The Gethinger
Skilled welders connected the framework, creating a rigid spine for the station.
These lower levels would house logistics and parking, designed to keep traffic flowing smoothly.
Quality control was rigorous, with every square meter inspected for durability. By 2022, the structure finally breached the surface, ready to rise into the sky. Extensive scaffolding was erected to support the construction of the platform level.
Prefabricated components sped up the process, assembled like a giant puzzle. Precision coordination between crane operators and ground crews was essential.
The footprint of the station was now visible, a massive rectangle carved into the district.
The core of the station, the rail platforms, began to take shape. Solid concrete beds were laid to support the high-speed trains of the future.
15 platforms were constructed simultaneously, to handle the expected passenger volume. To maintain speed, the project deployed an army of AI-driven construction robots.
Wall sanding robots worked tirelessly, preparing surfaces for finishing.
AI-powered safety patrol units roamed the site, monitoring for hazards.
These units ensured every worker followed strict safety protocols.
The architectural signature began to emerge. Massive columns designed to look like trees.
These tree-like columns are not just decorative, they support the massive roof spanning overhead. Welding these complex curves required the most skilled hands on the project.
A forest of steel trees rose up, defining the station as vertical metropolis concept. As the structure grew to 8 stories, the lifting requirements became immense.
Working at these heights required nerves of steel and absolute precision.
Even on the upper floors, robots handled the heavy labor of concrete leveling.
By late 2023, the focus shifted to preparing for the most challenging phase, the roof.
The central waiting hall, the heart of the station, was now ready to be covered.
Miles of electrical cabling were embedded within the walls to power the smart station.
Laser scanning robots verified that every beam was within a fraction of a millimeter of the design.
The station was rapidly becoming a landmark in the Nan'an district.
For the thousands of workers, this was more than a job. It was national pride.
Under the lights, the steel forest waited for its canopy. Every bolt was tightened to exact specifications to withstand wind and vibration.
The open design allowed for natural airflow, a key part of the eco-friendly plan. Installation of the vertical transport systems began, linking the 8 stories together.
Logistics on the site were managed with military precision.
The dedication of the workforce drove the project forward through all seasons.
The grand entrance began to curve upwards, welcoming the city.
The steel rails, the veins of the station, were finally being laid down.
Automated track-laying machines ensured a perfectly smooth ride for high-speed trains.
The skeleton was finished. Now, it was time for the crown.
2024 brought the massive steel roof assembly, weighing a staggering 16,500 tons.
The roof spans 120,000 square meters, a jigsaw puzzle of engineering.
Giant crawler cranes lifted steel trusses weighing hundreds of tons into the sky.
High-altitude teams received the suspended steel, guiding it to the millimeter.
Once aligned, massive pins locked the structure together.
The lattice design provides strength while minimizing weight. Piece by piece, the station was enclosed, shielding it from the elements.
Walking on narrow beams, workers demonstrated incredible bravery and balance. Automated welding robots were used on the roof to ensure watertight seals.
The robotic welds were flawless, crucial for a roof of this magnitude. Openings were left for extensive skylights, designed to flood the interior with natural light. These skylights are a key feature, reducing the need for artificial lighting.
A major milestone was reached, marking the end of heavy structural work. The roof's shape mimics the rolling terrain of the surrounding mountains. Layers of insulation were added to regulate the station's temperature efficiently. The final skin of the roof, durable metal cladding, was secured in place. Tested by the elements, the new roof channeled rainwater away effectively.
Inside, the play of light and shadow began to bring the architecture to life.
With the roof self-supporting, the temporary internal scaffolding could be removed. The removal of supports revealed the breathtaking scale of the column-free space.
The skylights looked like jewels embedded in the metallic skin.
Safety systems were installed at the very peak to protect the structure. A 120,000 square meter marvel of steel and engineering was now complete.
With the shell finished, the focus turned to the futuristic interior.
The facade required massive glass panels, some weighing over 800 kilograms.
Specialized glass installation robots were used to handle this delicate, heavy load. These robots maneuvered the glass with a precision no human crew could match. Workers secured the panels, safe from the strain of heavy lifting.
The glass curtain wall enclosed the station, merging the interior with the landscape.
Inside, acres of polished stone flooring were laid for the high-traffic areas.
Satellite. Massive LED screens were installed to guide the 16,000 hourly passengers.
Smart ticket gates were wired up, ready for the flow of travelers.
Thousands of seats were installed, arranged for comfort and flow. Commercial zones were fitted out, integrating shopping and dining into the hub.
Escalators and elevators underwent rigorous testing to ensure reliability.
Greenery was brought inside, creating an eco-friendly oasis for passengers. The lighting systems were tested, illuminating the architectural details.
Finishing touches were applied, polishing every surface to a shine. Safety was the final priority, with comprehensive tests of fire suppression systems.
By early 2025, empty trains began trial runs to test the tracks and signaling.
The nerve center of the station came online, monitoring every movement.
Massive cleaning crews prepared the station for its public debut.
The station's name was lit up, a beacon for the city.
The vertical metropolis was now ready for the world.
June 27, 2025. The sun rises on a new era for Western China's transportation.
The doors opened, welcoming the first of millions of passengers.
Travelers were greeted by the stunning tree-like columns and natural light. The first high-speed trains arrived, connecting Chongqing to Beijing, Shanghai, and beyond.
Advanced AI systems processed passengers smoothly and efficiently.
The construction robots were gone, replaced by service robots assisting travelers.
The station truly came alive as a vertical metropolis, buzzing with energy.
More than a station, it is a new urban district, fully integrated with the city.
From rugged mountains to a modern marvel, achieved in just a few short years.
This is the Chongqing East Railway Station, a testament to Chinese engineering